Sup guys, welcome to today's show. So, last time we learned about this AND gate. And this is the symbol. We have two inputs, A and B, and an output. And this right here is the truth table. So, if both A and B are 1, then the output is 1, otherwise 0. So, we also built one of these AND gates, and if you want to check out that episode, I'm going to put the electrical engineering playlist in the video description. But today we're going to talk about another type of logical gate, and it looks something like this. So, same principle. We have two inputs, A and B, and we have one output. The truth table, however, looks a little bit different. So, since it's an OR gate, if we have both 0, it's going to be 0 as output. But if we have A as a 1 and a B as a 0, or vice versa, in that case, the output is a 1. And if we have both A and B as 1, the output is a 1. So it works pretty much like the OR operator in C. So if A or B in that case we return 1, otherwise we return 0. Simple enough. And how are you going to remember all of these different symbols? They are quite similar. And my tip is that you make sure to learn the AND symbol, because it's the most simple one. Just looks like this. And if you know this one, then you can think of the OR gate as this curve here is like an O. That's how I remember it. So I start out thinking about an AND gate, and then I make this curve like an O, and that's an OR gate. So it's quite easy to remember if you use that mental model. And same as using the AND gate, we can build on this one by combining it with other OR gates or with other AND gates and other types of gates, and create any type of logic. So let's see if we can build one of these things. So if we start out with the power source, so we have the plus and the minus side. And let's start by connecting a small resistor. And this I will only connect to make sure that the light is not that we don't put too much electricity through the LED. So here we will have the LED, and the output will be here. So basically, if this light is on, then the output is on. So how do we make that happen? Well, we need to use transistors, same as the AND gate. but we can't connect them in a series. But because if we connect them in a series, then both must be active in order for this to work. So instead, we're going to do something like this. So let's say we have a transistor here. So it looks something like this. And here we will have the A input. And here we can connect, let's see here. We connect this to another resistor. And why do we do that? Because when we put electricity on this A, we don't want it to be a short circuit. So we will have a 1K resistor here and a 100 ohm resistor here. And I'll use this syntax R as resistance. But this 1K is actually 1K R, but I will only write it as 1K. That's just a side note. All right, so we need to connect those in parallel. So let's create another transistor right here. And this is going to be the B input. And same, we will connect it through a 1K resistor to ground. So something like this, because by default there will not go any electricity here because it will not pass all the way to the minus. However, if we activate this A transistor, and we will do that by connecting it to the plus side like this. So this means that electricity will flow through the middle leg of this transistor, through this resistor to ground. And that will activate this, which means that electricity will also flow through this LED, through this transistor to ground. And actually, I think I'm gonna change this a little bit. I want to put the, let's see here. Let's put the 1K resistor here instead. So this is 1K, this is 100 R, and this will be straight connected like this. And why do I want to do this? Well, I don't want this to pass through two different resistors. And that was my teacher assistant passing through. Move along, cats. Catsy. All right, so in this case, this transistor will be on. But we also want to be able to go through this one. So we'll do the same thing here. I'm going to put a 1K ohm resistor. And I'm going to connect this to the plus side like this. So if, let's see here. If both of these are active, it will take the shorter path and go through like this. But if we disconnect this one, then the electricity will flow in this direction, activating the B transistor, which means that electricity will flow through this. So as you can see, this is very similar to the AND gate. The only difference is these transistors are connected in parallel instead of in series. And before we begin building, I want to show a different way of illustrating this. Because the sketch I showed you right now is how you will connect it. But since we can assume that all the ground connections are connected together. So if we have two ground connections like this, we assume that they are connected like this. And same for the 3.3 volt connectors, which I will draw like this. Plus 3.3 volts. And if we have several of these connections in our sketch, they will be assumed to be connected. And of course, the plus and minus side will not be connected, but they will be connected to the same kind of power. And with that in mind, we can create this not as a rectangle, but as one or several lines, which makes things a little bit easier. So let's say we begin from the plus side. So we have the plus 3.3 volt. And the first thing that we will encounter is our 100 ohm resistor, like this. And then we have our LED light. Like so. And we will also have the out connector here. Then we come to the first of the two transistors. So let's draw it something like this. And then this is connected to ground. And this is the ground connector symbol. And then we have the A input connected here. And in parallel with this, so we'll do something like this. We have the second transistor also connected to ground. And this is the B connection. So this is a little bit easier to read, I think, but it's the same thing. The only thing is we don't make it as a rectangle. And if we have a complicated sketch, this way will be easier to draw, basically, and to interpret. All right, so let's see if we can build this thing. We'll be right back after this. All right, guys. So I want to start by talking a little bit about this thing. So this is a breadboard, a very useful tool when creating prototypes and temporary circuits. So it works like this. There's a lot of holes here where you can put in components, and each of these lines of 5 holes are connected together. So these 5 are connected, these 5 are connected, but those 2 lines are not connected to each other. And same on this side, but not on this side and not on the next line. So this makes it very easy to connect stuff, because you can put in, let's say, an LED, and you put one leg in this hole and one leg here, and then you can just connect other stuff by using the same line. Then we have these so-called power rails on the end here, or on the sides. They work a little bit differently. They are not connected across a line like this, but the whole row is connected. So these are primarily used in order to connect power. So on the red side, we usually connect the plus side, the 3.3 volt or whatever. And on the minus side, the blue line here, we connect the negative side, ground. And these 2 power rails are not connected to each other in any kind of way. So that's why I usually put cables like this. So I connect the plus side on this side to the plus side on this, and same with the minus side. And this makes it very easy to connect power, because you can use any hole on each side. All right? So that's how a breadboard works. All right, so let's create this OR gate. I'm going to start by taking around 100 ohm resistor. I think it's 82 or something. And I'm going to connect this to the plus side, like this. And then in series, I'm going to connect this LED light. And please note that the legs are in different lengths. The longer leg should be connected to the plus side. So I'm going to connect it something like this. Then we'll continue in series and connect one of these. This is a transistor, an NPN type transistor. So I'm going to take the rightmost leg and connect it to the same line here as the minus side of the LED. So something like this. And when we created the AND gate, we connected the second transistor in series like this. But this time we need to connect it not in series, but in parallel. So what I'm going to do is I'm going to take this jumper cable and I'm going to connect it to the other leg here. So not the side that's connected to the LED, but the other side, to gain some space. So I'm going to connect it something like this. Okay. Because now I want to put this in parallel. So let's see here. No, mistake. Let's remove this. I want to
if I were connecting it like I did now, it would be in series, but I want to connect it in parallel. So I will connect this to the other leg, the first leg, like so. And now we can take the second transistor and connect it in series with this connection. So now these two transistors are connected in parallel. Now they are connected in parallel. Okay? So next I'm gonna take two 1000 ohm resistors and I'm gonna connect it to ground on this side, like so. So this is where we want to connect the middle leg later on. And same with the second resistor, also 1000 ohms. And next I want to connect the rightmost leg of this second resistor, ground. I'm going to use one more of these small jumper cables. I'm able to connect this thick. This is all right. But we also need to connect the first transistor to ground. So let's see. Let's use another one of these small jumper cables. So same here, the rightmost leg should be connected to ground. So I'll do something like this. It's not very neat, but it'll do the job. If I'm able to connect this thing. So something like this. Alright? And now we need to connect the middle legs. So the middle legs are going to be the A and the B inputs. So I'm going to take a jumper cable like this and connect one of these colored cables to the center leg of the first transistor. And same with the second one. So something like this. And then I'm gonna connect these to the plus side. Let's see. No, I'm gonna connect it to the minus side to begin with, which means that these are a logical 0. So now the light should not light up. Let me just get some power. So I'm going to connect power. And as you can see, it's not lighting up. But if we take the first input and we change it to a logical 1, then it should, light up.
Alright guys, welcome back. So I finally figured it out. I cleaned this design up a little bit. So now I am sending both inputs as 0 and it does not light up. So I set the A input to 1 and it lights. I set the B input to 1 and I set both inputs to 1. So now it works as intended. So let's take a little look here. So we start out by going from the plus side here to the first leg of the first transistor. Then on the other side of this transistor, we go from this jumper cable to the right leg. So I connect the right legs in parallel of the transistors. And I also connect the right leg of the first to ground through a resistor. So if this first, if we send in a 1 from here to the middle leg of the first one, the electricity will flow to the right side of this transistor and through this resistor to ground. And if we send in a 1 on this one, it will flow through the middle leg to the right side, through the LED and to ground. And if any of these are true, electricity will flow here from plus through the leg of this one or through the leg of this one, through this LED. So this is how it's done. I hope you liked this episode. Please like, subscribe, and thanks for watching. Thanks for today.